Okay, x to the, what am I going to get? Negative 3/2. Because negative 1/2 or negative 3/2, right? We use improper fractions here because they're easier to deal with. So negative 1/2 minus 1 gives you negative 3/2. You got that one? Show of hands, how many would feel okay with getting that far on our problem? All right. Let's make it a little bit prettier. Simplify some fractions. That's 1. That's 2. There's a third one. In the most basic sense, that's your derivative. No problem. What is that? What did I just find? What is that we found? Oh, come on. What is it? What's the derivative? Slope of a curve. Now, the slope of this curve, this weird curve, at any point. It's kind of neat that we're able to find that, right? We don't even know what the curve looks like. Yet we're able to find the slope of that at any point. We have a function for it. Now, if you do want to make this a little bit nicer looking, you can translate these back into roots if you really so desire. You could do, well, I probably wouldn't change that one at all, unless you want to do it. Square root of x to the 7th, that's what that means. So if you really are forced to do it, here's how you would change this back into roots. For me, most of the time that's going to be fine, but if you're forced to plug numbers in, you want to see what's actually going on here. So this would be 3 square root x to the 7th over 2. Minus, since that's a negative, it will be on the denominator of fraction, 3 square root of x. Since that's a negative exponent, it will be on the denominator of a fraction along with that 2, a square root of x cubed. That's the way you would write that without any negative exponents associated with them.
But for your classmate, you just leave it.
Most of the time, we're going to be okay on that. However, typically, if they get root form, you want to make it back into root form. So in that case, that would be maybe what you see in the back of your book, or some other context. Some people feel okay with our example up here. Like that. So, can we do this term by term by term by term? Can we do that? No, we cannot separate division. We can't do that. What we can do is separate our fraction firstly, then simplify each of those, and then take a derivative. That's something we can do. And that it's not too bad. We've dealt with a lot of fractions here, but I mean, that's some algebra. We should be okay with our fractions. Are there any questions before we move on at all? Do you like this derivative business? Can you imagine taking the limit of that? Of x plus h? Woo. Good thing we had that. Seriously? I'm on the edge. That's the only way you know how.